Welcome to the debate. You know, for the better part of a century, physics has been haunted by this single glaring silence. We have general relativity, Einstein's masterpiece, describing the grand curvature of the cosmos, stars, galaxies, gravity. And then we have quantum mechanics, describing the jittery, probabilistic world of the atom. They're both wildly successful, they're both experimentally proven, and yet mathematically, they refuse to speak to each other. They're incompatible.
It is the grand divorce. And usually when someone claims to have fixed it, to have found the theory of everything, they present something so complex it requires, 11 dimensions, vibrating strings no one can ever see, and math that just loops back in on itself?
Usually, yes. But every so often, a manuscript crosses our desk that tries to shatter that silence, not by adding complexity, but by changing the fundamental geometry. Today, we're dissecting a 2026 manuscript titled Supersymmetric Geometric Quantum Mechanics, the Aetheron Model. It proposes that the stagnation in physics isn't from a lack of data, but from a failure of perspective.
And that is a very bold claim. I mean, we are looking at a model that introduces SGQM, and frankly makes some assertions that should make any standard physicist uncomfortable. It claims to solve the mass gap, unify the four forces, and explain the fine structure constant. But the price of admission is high. It asks us to accept a concept that physics buried and held a funeral for over 100 years ago, an ether. So the question we need to answer today is simple. Is this the grand unification we've been waiting for, or is it just an overly complex geometric abstraction that drags us back to the 19th century?
I think drags us back is a bit harsh, though. I do anticipate your hesitation. I'm representing the perspective that SGQM offers a mathematically elegant and deterministic unification. It suggests that the universe isn't a container of objects floating in a void, but a living, rotating geometry. It moves us away from abstract point particles and towards a structured manifold.
And I'm here to represent the view that, extraordinary claims require extraordinary evidence. This model posits a non-propagation hypothesis, the idea that light and gravity don't actually travel. That is a massive departure from Newton, Maxwell, and Einstein. So I'm here to kick the tires and see if this engine actually runs, or if it's just pretty mathematics.
All right, let's open the hood then. The central pillar of this entire framework is something the author calls the Aetheron theorem. To really get it, we have to look at how we currently view mass and energy. We usually treat them as separate buckets. Einstein connected them with E equals mc squared, but they're still distinct properties.
Right. Mass is resistance to acceleration. Energy is the capacity to do work. We measure them differently.
SGQM argues that this distinction is an illusion caused by our perspective. The model argues that we've been looking at a 2D picture of a 3D reality. It introduces a Pythagorean invariant. Alpha squared equals mu squared plus E rot squared.
Okay, let's pause and unpack that for a second, because equating the fine structure constant to a geometric hypotenuse is a massive leap. So mu here is the mass term, and E rot is rotational energy, and alpha, that's the fine structure constant, roughly 1 over 137. It's a pure number for the strength of electromagnetism. How do you square a number and get mass?
By realizing that mass isn't a thing in this model. Mass is a geometric projection. Think of a ladder leaning against the wall. The ladder has a fixed length. That represents alpha. It is the fundamental structural limit of the geometry. The distance from the base of the wall, that's mass. The height up the wall is energy.
I followed the analogy. So the ladder itself, the alpha, never changes its length.
Exactly. If you change the angle of the ladder, you trade distance for height. You trade mass for energy. But the ladder itself, the fundamental geometric reality, never changes. This implies that the distinction between matter and force is just a matter of perspective, or rather rotational phase. A particle is just a geometric form rotated in a specific way. If it's rotated one way, we see it as heavy, having mass. Rotated another, and we see it as energetic. They are orthogonal projections of a single unified rotational invariant.
I will grant you that is an elegant mathematical trick. It cleans up the relationship between rest mass and energy using the Pythagorean theorem, which is satisfyingly clean. But the structure required to support this latter is immense. The manuscript states this happens on a 12-dimensional manifold. M12. We live in 4 dimensions. 3 of space, 1 of time. String theory asks for 10 or 11. This wants 12?
Well, it's a specific topology. M12 approximates to M4, our familiar spacetime, multiplied by F8, which is an 8-dimensional internal fiber. It's not just random dimensions, it's a specific mathematical architecture.
Internal fiber is doing a lot of heavy lifting in that sentence. That's a lot of room for convenient variables to hide. But my biggest issue isn't the number of dimensions. It's what happens, or rather doesn't happen, inside them. We have to talk about the non-propagation hypothesis.
I suspected we'd get here quickly.
It's the elephant in the room. The model claims that light, gravity, and information do not travel through space. It says that what we perceive as movement is actually a local phase resynchronization.
Correct. That is the core claim.
I'm sorry, but I just don't buy that. Let me tell you why. We have centuries of evidence. When I shine a laser at the moon and it bounces back 2.5 seconds later, that light, it traveled. It went there, it hit the surface, and it came back. If you say light doesn't propagate, you are fighting a lot of history.
The model doesn't deny the time delay. It reinterprets the mechanism. Think of a stadium wave. You know, the Mexican wave fans do at a soccer game? You see a wave travel across the stadium, right? It clearly moves from section A to section B.
Sure, it moves around the arena.
But do the people travel? No. The people just stand up and sit down in their local seats. They don't run around the stadium. The wave is a pattern of local synchronization. SGQM argues that the universe is a lattice, a solid-state geometry called the Aetheron. Photons are not bullets flying through a void. They're ripples of phase adjustments passing through this lattice.
Okay, the stadium analogy is helpful, but it breaks down when you look at the actual physics. If the universe is a lattice of people standing up and sitting down, that implies a medium, a background. And back in 1887, Michelson and Morley tried to find that medium. They looked for the luminous aether. They assumed that if Earth is moving through this medium, we should see a wind. Light should travel at different speeds depending on which way we're moving, and they found nothing. 0. The speed of light was constant. That killed the aether. Why are we digging up a corpse?
Because they were looking for a fluid wind. They were looking for something dragging against the Earth, like air flowing over a wing. The Aetheron isn't a fluid. It's a 12-dimensional rotational manifold, a tensor field.
Okay, define tensor field for the non-mathematicians here.
A tensor field just describes the stresses, the strains, the rules of a geometry at every single point. Think of a rubber sheet. The Aetheron model says the Earth isn't a marble rolling on the sheet. The Earth is a complex knot in the sheet itself. The Earth is a topological excitation of the Aetheron. You can't feel an aether wind because you aren't moving through it. You are made of it. You are a ripple moving through the rug. A ripple doesn't feel friction against the rug because it is the shape of the rug.
That creates a very different mental image. So you're saying the null result of Michelson-Morley was correct, but their assumption about what they were testing for was wrong?
Precisely. Michelson and Morley failed to detect a wind because there is no wind to detect, only local geometric adjustments. These adjustments are governed by what the manuscript calls the 32 mixed generators of the spin-12 group.
That's a compelling argument, but what about the speed of light itself? If c is just a sync rate, the rate at which the people in the stadium stand up, is it constant? Standard physics says c is invariant. It's the law.
And this is where SGQM gets really interesting. It predicts that c is a geometric parameter determined by local curvature. So yes, it predicts variations in regions of extreme curvature like near a black hole event horizon or within these dense Aetheron knots. The synchronization rate changes. It challenges the absolute constancy of light speed in favor of geometric consistency.
Which brings us to the knots. You mentioned the Earth is in excitation. Let's pivot to particle physics. The Standard Model gives us this very specific zoo of particles: quarks, leptons, bosons. It's a messy list. How does a geometric model account for the difference between a top quark and, say, an electron?
This is one of the strongest sections of the manuscript, I think. It treats particles not as point-like dots, but as Aetheron knots, stable topological excitations. To understand this, we have to look at spin. We know fermions have spin 1/2. This means they need to rotate 720 degrees, not 360, to return to their original state.
Which has always been a mathematical oddity. If I turn around once, I'm facing you again, but an electron has to turn around twice.
Exactly. Think of the coffee cup trick. You hold a cup of coffee in your hand, palm up. If you rotate it 360 degrees without spilling, your arm gets all twisted. You're back to the start position, but your state, your arm, is stressed. You have to rotate it another 360 degrees, passing the cup under your elbow to untwist your arm. That is spin 1/2. SGQM explains the why. It breaks down the 12 fermions as a product of 4 specific fermionic axes, R1 through R4, interacting with 3 winding states.
So these axes are like the threads in the loom?
Think of them as the fundamental directions of rotation. R1 is the spin sync axis that gives you neutrinos. R2 is the charge phase axis that creates charged leptons like the electron. R3 is mass coupling, generating down-type quarks, and R4 is color rotation, generating up-type quarks.
So the particle's identity depends on which axis is active?
And how tightly it's wound. The 3 generations of matter, why we have the electron, the muon, and the tau, are just higher windings or topological tightness of these same 4 axes. It's the same knot, just pulled tighter. A tighter knot stores more tension, more energy, which we then see as higher mass.
I can appreciate the reductionism there. Getting 12 particles out of 4 axes and 3 windings it's tidy. But let's talk about the forces, specifically gravity. We've been hunting for a quantum theory of gravity for 80 years. String theory invents gravitons. Loop quantum gravity digitizes space. How does a rotating lattice explain gravity?
It goes back to the geometry. The manuscript identifies Einstein's famous 8π factor in his field equations. Usually, we just treat that as a constant to make the units work out. SQGM says that 8π is the synchronization constant. It represents a full 1440-degree closure cycle of the manifold.
1440 degrees, that's 4 full rotations, or 2 of your fermion cycles.
Exactly. It unifies the matter cycle with the field cycle. The graviton, which is spin 2, is defined geometrically here. It isn't a particle flying through space. It is the result of 2 simultaneous orthogonal 360-degree rotations, one in the mass plane and one in the curvature plane, offset by 90 degrees.
That's a lot of geometry to replace a simple force carrier. But here's my issue. If this is a supersymmetric theory, where are the superpartners? Standard supersymmetry predicts a gravitino with spin 3/2. We have smashed atoms together at the LHC for years. We haven't seen it. If your theory depends on supersymmetry, and we can't find the particles, isn't the theory dead on arrival?
I'm not convinced by that line of reasoning, because you're looking for a particle in the traditional sense. SGQM defines the gravitino differently. It calls it the supersymmetric hinge. It's a hybrid state bridging the fermionic sectors, R1 to R4, and the bosonic sectors, R5 to R8.
A hinge?
Think of a door. You have the wood, the matter, and the frame, the field. The hinge connects them. It isn't a free particle waiting to be detected in a collider. It's the structural mechanism that ensures topological closure. It's the glue, not a brick. Its job is to ensure coherence between matter and field. You don't see the hinge when the door is closed, but it holds the whole thing together.
So it's convenient that we can't see it?
It's not that we can't see it. It's that we've been misinterpreting what it is. It's a transition state essential for the topology, but not a stable knot like an electron.
I want to touch on the philosophical implications for a moment before we get to the experimental proofs. This idea of a lattice, of synchronization. It sounds familiar.
It resonates deeply with David Bohm's implicate order.
Right. Bohmian mechanics. The idea that there are hidden variables determining quantum outcomes.
The manuscript argues that the pilot wave in Bohmian mechanics, which guides particles, is actually the structured rotational dynamics of the Aetheron Model. It suggests that quantum randomness is an illusion. It's just the 4D projection of deterministic high-dimensional phase dynamics.
And that removes the spookiness from action at a distance.
Exactly. Entanglement isn't magic communication faster than light. It is rotational memory. If two knots are formed from the same topological event, they share a continuous manifold connection. They're part of the same geometry. If you pull one end of a rug, the other end moves. Not because a signal traveled, but because it's one single rug.
But that just replaces spookiness with a rigid geometric determinism. If the lattice determines everything, then the future is mathematically set. But that's a debate for a philosophy show. I want to stick to the physics. This is a beautiful model, I admit. It weaves Bohm, Einstein, and quantum mechanics into a single rug. But beautiful theories can be dead wrong. I demand the kill switch. How do we prove this wrong? Does the manuscript offer any specific, testable predictions that differ from standard general relativity?
It does. It offers 3 specific, falsifiable predictions. And this, you're right, is where the rubber meets the road. First, it points to LIGO data. When 2 black holes merge, they ring down, like a bell settling into silence. General relativity predicts a smooth decay. SGQM predicts gravitational echoes. Because the Aetheron is a lattice, the restructuring of that lattice governed by the rotational correction tensor F mu nu should cause distinct deviations, or echoes, in that final signal.
Okay, that is testable. We are getting better resolution on gravitational waves every year. If we see bumps in the ring down, that's points for SGQM. What else?
Second involves Mercury. We know general relativity explained the precession of Mercury's orbit by accounting for curved space. SGQM accepts that, but adds a magnetic leakage effect.
Magnetic leakage? Gravity isn't supposed to care about magnetism?
It does in a unified manifold. The model claims there's a coupling between the R6 axis, which handles electromagnetism, and the R7 axis, which handles gravity. Because the Sun has a massive magnetic flux, SGQM predicts that Mercury's precession should correlate with changes in the Sun's magnetic cycle. If we analyze the data and find that the precession wobbles in time with the solar cycle, GR can't explain that. SGQM can.
That is actually very specific and likely measurable with current orbital data if we look for it. If there is no correlation, the theory breaks.
Exactly. And that is what makes this a scientific theory, not just philosophy.
And the third?
The third involves the fine structure constant, alpha. We treat it as a fundamental constant of the universe. But remember the Aetheron theorem? Alpha is the hypotenuse of a dynamic triangle. SGQM predicts that in high gravitational fields, the geometry distorts. Therefore, alpha should vary. We should see shifts in atomic spectra near massive stars that we don't see in a vacuum.
Variability of fundamental constants. That is a bold prediction. Standard physics says alpha is constant everywhere forever.
So there you have it. It's not just philosophy, it's a target board.
So where do we land? We have a model that unifies mass and energy into a geometric invariant. It explains the particle zoo through topological knots. It reinterprets gravity as a synchronization force, but it asks us to abandon the idea of light propagating through a void and accept a 12-dimensional solid-state universe.
It asks us to stop looking at the actors and start looking at the stage. You're right to be skeptical of the non-propagation hypothesis. It's intuitive to think of photons as bullets. But if we look at the failures of the last century, the inability to quantize gravity, the mystery of dark matter, maybe our intuition is the problem. SGQM suggests that empty space is the most substantial thing there is.
I will concede this. It is a braver attempt than string theory has been in recent years. It actually makes a prediction about Mercury I can go out and check. But until I see those gravitational echoes in the LIGO data, or that magnetic wobble in Mercury, I'm sticking with the idea that light travels. I'm not ready to live in a frozen crystal lattice just yet.
That's fair. But consider this final thought. When Einstein wrote g mu nu equals 8 pi t mu nu, he put that 8 pi there to make the math work. If SGQM is right, that 8 pi isn't just a number. It's the heartbeat of the universe, a 1440-degree cycle that breathes existence into every particle in your body. It suggests we aren't just in the universe, we are woven out of its very geometry.
A poetic thought, certainly. Whether it's true, well, the data will decide.
As it always should. Thank you for joining us on the debate.
Keep questioning.